something I'm pretty sure you've seen before. But we're going to discuss it in detail. Let's see some applications and so on. So first, let's start with the definition of, let's talk a little bit about the exponents before we go to the order of operations itself. Let's review exponents a little bit. Exponents or powers pretty much mean the same thing. For instance, when you have an expression like this, how do we say this expression here?
2 to the third
2 to the third power.
2 to the third.
Exactly, 2 to the third power. And so 3 is the power. What's 2 if 3 is the power? What do we call 2?
The base, not the base.
That's right, it's the base.
The base.
Say no more. Okay, you got it right, the exponents. So this is the exponent, this is the power. And again, what's under the power is called the base of that number. So this raised to this power, so 2 to the third or 2 raised to the third power. So that's how we say that expression. But how do we simplify it? What is the value of this?
2 times 2 times 2.
6. Oh.
Not 6, I was going to say not 6. So it's not 2 times 3, it's not 6, it's 2 times 2 times 2, that's right.
All right. 2 right.
8.
That's right, so this will be 8. So it's always multiplications between the numbers. So the base is repeated or is multiplied by itself this many times, whatever the power is. So in this case, 2 times 2, that's 4 times 2, that's 8. Okay, so that's basically how exponents work. Again, do not just times these, that's not how it works. You have to expand this, you have to break it down, expand it, and then multiply 2 at a time. Let me give you another example. So, please mute your mic, whoever has noise. Please keep your mic muted until you're ready to talk. So that's one example. Let's do another one. Here's another one. How do we say this?
3 to the 4th power.
3 to the 4th power.
That's right. So the base is 3 raised to the 4th power, 3 to the 4th. And again, the value, it's not 3 times 4, it's not 12. What do we do instead to find the value of this?
You're just going to express it, the base 4 times.
That's right. It's going to expand it. So we're going to expand this, going to multiply this base by itself this many times the power, 4 times. So 3, 1, 2, 3, 4. If you have 5, it's going to be 5. If you have 7 here, it's going to be 7, and so on. So this is what we call the expanded form. And from here, once we expand it, then we do the multiplications. You can do 2 at a time. You don't have to multiply all these at the same time. So, just do 2 at a time here. That's 9. Multiply by
18.
9 again. 9 and 9. Then we times these 2 also. What we get? 81.
81.
Right? 81. So this is the value. So it says, usually we say evaluate. Evaluate this, for example. To evaluate it, to do this basically, and to find the value. So the value of this exponent or the expression is basically 81. Most of the time, especially if the power and the base are smaller or small, we just expand them and do some multiplication. But if the power is too big and the base is too big, this could be a very large number, which may take a while, if ever possible, to do manually. So it may take you a long time. But we can do this with a calculator. Every calculator has a button where you can plug when the numbers are too big. We're not going to be using it in the class. I'm just letting you know. So each calculator has a button x, y. X is for the base, y is for the power. You just put in the base and the power and it immediately gives you the answer. This is especially useful when you have big powers and big numbers here, billions or trillions. For example, 20 to the power 17. This is a very, very big number. And to do it manually may take you a lot of time, but it can be done in a calculator very quickly. And each button in the calculator, again, each calculator has a button like this where you can do this immediately when needed. But for in this class, most of the time you see some reasonable powers and bases, so it's not going to require this. To the fourth, this also applies to fractions. If you have, let's say, 2/5 as a base and raised to some power 3, same thing applies. So we just need to repeat this, multiply the base. This is the base this time, the whole thing, multiply by itself 3 times. So 2 to the 5th, multiply 2 to the 5th, and so on. Then you may multiply all at the same time, or again, you can do 2 at a time. Let's multiply these 2 first. What's 2 to the 2/5 times 2/5?
4/10.
10/1.
I'm sorry, say that again.
Isn't it 1? 1 whole? Because
4/5?
Oh,
Four
no,
over
I'm sorry.
25.
No, it's not. It's 10/25. I'm sorry.
4/.
I didn't hear the correct answer. I heard a bunch of answers, but none of them were correct.
4/25.
4/25. That's right. That's better. So just multiply straight across. This is a multiplication. We multiply. And then bring this one down. Multiply again. What do you get?
8.
Straight across.
50.
125.
125. That's right. Just multiply straight across. And you get your answer. So that applies to all sorts of numbers. The base and the power could be any sorts of numbers, negatives, they could be positives, decimals. But the same rule applies. Expand, then multiply. And so the base could be a positive number, could be a fraction, or it could be a decimal. There could be a negative number with the expression, for example, -3 to the second, or something like this, which is not the same, -3 parentheses to the second. These are not the same, okay? They're different. The format is different, the value is also different. What do you think this is equal to? What is the first one here? Equal to, or the second one?
The minus,
Oh, I'm sorry, say it again.
the minus, you're going to minus by minus, plus. You can see that.
That might work here because the base is -3 because we have parentheses. So everything inside here, the parentheses is the base of 2. So we can multiply the base by itself, expand it, just like we did here and here, and you get +9. But here, the base is 3, not the -3.
Okay.
2 is the power, 3 is the base. This has nothing to do with this. The minus is independent. Just write it down.
That's
Okay,
nice.
write the minus down, and then we expand this. Expand 3 to the second. What is it? If you expand it 3 times,
9, 9.
3 times 3, that's right. Again, bring down the minus. It's dependent here. It's not part of the base.
Oh, okay.
And you get 9. Okay, so that's important, everybody. So look at this, with these two here. The base is -3 because of the parentheses.
Because of the parentheses.
Right. So when we expand it, we have to multiply this by itself. -3, -3, depending on the power. If you have 5 here, it's going to be -3, -3, 5 times. But if you don't have the parentheses, the base is just 3, not this. We don't have this. So this is not part of the base. So bring it over and expand this. 3 times 3, you get 9.
So 1 3 is negative and the other one is positive in that case.
Yes, so if you have a minus here, it's always going to be there. But if you have a minus here, it will depend on the power. Expand it, as many times as the power and multiply. You could end up positive or you could end up negative. It will depend on how many you multiply. But here, if you don't have parentheses, this minus will always be here. So let me give you an example. Let's say you have negative 5 to the second versus negative 5 to the second. Again, they're not the same. What is this first one equal to?
That is gonna be actual -5 because it's in the parentheses. So it's gonna be -5 times -5.
Okay, which is
A positive
Neg-
25.
Right, positive 25.
positive. That's right. Negative times a negative. What about this one?
Minus 5.
Minus 25. That's right. So
Correct.
this stays here. So basically just bring this minus here. Bring it here. This minus may turn into positive or not, depending on this, depending on how many you multiply. Each 2 will turn into a positive. So expand the whole thing, multiply, you may end up with a positive or negative, but here the negative will always be there. So this does not turn into a positive. The negative stays here because it's not part of the base. Okay, so that's important when it comes to powers and the negatives. The negatives in the base or next to the base. That's what happens. Another thing is when you see, let's say, a negative in the exponent. It could be a negative in the exponent. So before you say -9, this is not -9, okay? 3 to the second is 9, but 3 to the power -2, it's not -9. Does anybody know? I'm not expecting you to necessarily know what it's equal to, but does anybody know what it is equal to or how to find out? Everybody, what do you think about this problem?
Is it
So-
6?
Not 6, not -6, not 9, not -9.
A positive 6. Yeah.
But it is
Oh.
not.
So
But-
let me give you, so here's the deal here. So 3 to the power -2.
A positive 9.
Nope, not +9, not -9. So here's what you do. When you have a negative power, what you do is make it into a fraction if it's not a fraction, and we move this expression to the other side to make it positive. So we move this down, becomes 3 to the power 2, or +2. The exponent or the negative exponent becomes positive when we move it to the other side of the fraction. So when you have a negative power, you move it to the other side. If it's here, you move it up. If it's up, you move it down. Now we have a positive power, and 3 to the second is
9.
9. That's right. So instead of saying 9, we say 1/9. If you have 4 here, so instead of 16, we say 1/16. If you have 5, instead of saying 25, we say 1/25. So basically, we can do this in one step. So whenever you see something like this, think of it as a positive power first. What it would be with a positive power, then you say 1/, whatever it would be with a positive power. Let me give you another example. Let's say you have 5 to the power -2. What is this in one step? Just give me the final answer.
Just make the 2 a positive, and then
Or what's the
1 over
final answer?
25.
1/25.
1/5.
1/25.
Mhm.
In one step. Okay, you don't have to do these 2 steps at a time.
Oh,
Okay, so 5 to the power -2. So you say if it was a positive, this would be negative. If this was a positive, it would be 25. But because of the negative, flip it, say 1/25. Here, instead of 9, we said 1/9.
So if the exponent is a negative, it's automatically a fraction? Like
We
you turn
flip
it
it,
into a
yeah.
fraction?
We,
Okay.
yeah, we flip it or we move it to the other side, like so. So that's what you do when you have a negative exponent. Okay, so we can flip it or move it to the other side of the fraction. Okay, so that's another trick with exponents. So there is this minus that's here, or the minus could be next to the power. So this is what you do. What about, let me give you one more example. 7 to the power -2. In one step, what is this equal to?
One
1 over
One over
1 over
14.
49.
1
49.
over 49. That's right. 1 over 49 because 7 to the second is 49. But
Mhm.
this has a negative,
Professor,
so we say
question.
1 over 49.
Question.
Go ahead.
Here where we have, up, when we have -3 exponent 2 to the
Mhm.
second exponent, or, and
Okay.
you say that we only multiply the symbols when it's inside the parentheses, when it's outside we don't?
Yes, that's right. So this is part of the base. Negative here is with the base, but here the negative is not part of the base. The base is 3, not the negative. The negative stays here.
Okay, okay, okay.
Right? So, so that's a little introduction to exponents. So the reason we need to know how to simplify them like this is because we need them in the order of operations. So let's now talk about the order of operations. And so when we simplify expressions, for example, when you have, let's say, 5 plus 2 times 3, we need to do this in a specific order, not necessarily start from here and start from the first one and do the other ones. That's not how it works.
Multiply first.
That's right, we have to multiply first. So not the addition, but the multiplication must be done first according to the order of operation.
Mm.
So this would be 6 plus 5,
11.
and it would be 11. That's right. So we have a specific order for this. It could be 2 operations like this, or you may have 7 or 10 or more exponents, parentheses, a bunch of other things. Again, you don't have to invent anything. The order is here. I'm going to give you the order in a moment. You just have to follow it and do it in the right order to get the, should be only one correct answer. For any operation, should be one correct answer. So the order of operations is summarized here in this acronym. So each one of these letters stands for an operation. And when you have a bunch of operations together, you have to do them in this order. This operation first, then this one, then this one, and so on. So let's see what each one of these stands for. What does the P stand for in order of operations?
Parentheses.
Parentheses. That's right. So whenever you have an expression, always look for inside the parentheses first to see if you can simplify something there. Before adding, before doing any other thing, before the exponents, before the subtractions, you gotta work inside the parentheses. Once you're done with the parentheses, you move on to the next operation. What does the E stand for here?
exponent.
The exponent. So that stands for what we just saw. E for exponents, meaning if you have anything like this, you gotta evaluate it right after the parentheses. So the exponent is basically the second operation after the parentheses. Parentheses, or sometimes you may see brackets like these. You start the inside from the inside first. E, exponents. What about the M?
Multiplication.
That's right. Then D,
Division.
Division, addition,
Division.
and subtraction.
Addition, subtraction.
and subtraction. So that is your order here. That's why we did the multiplication first. So the multiplication is here. It comes before the addition. So we do it from here going to the right. So the multiplication was done before the addition here. So again, it's not always this first. You got to do it in the correct order. This is the only incorrect order that gives you all the, everybody should get the exact same answer, no matter how long the expression is, no matter how many operations you have, it should be the same. These two together, when you see them next to each other, we do them left to right. When you see these two together, whichever appears first. If the multiplication appears first, we do it first. If the division appears first, we do it first. Also, that applies to these two. To addition and subtraction, when you have them next to each other, whichever appears first is done first, also left to right. I'm going to see some examples of this in a moment. We can call these a couple of exceptions, okay? There's a couple of exceptions to PEMDAS, but other than that, the order is the same. Always follow the same order here. So I'll give you another example. So you may have a bunch of these in the same expression. Could have two operations like this. Again, you could have 10, you could have more. But let's make it a little longer this time, maybe 5 and 7 minus, let's say 4 to the second power plus 10. Okay, so there's a lot going on here. We have a bunch of operations. So first try to understand the expression. Just try to identify all the operations before you actually start solving.
Parentheses first.
That's right, so we'll have to do the parentheses. So let's first look at try to identify all the operations. So first, what is the operation here between the 5 and the parentheses?
Multiplication.
Multiplication.
That's right, so there's an invisible multiplication here. Then we have the parentheses, inside of them we have a subtraction, we have an exponent, then we have an addition. So when you see this again, the first thing you do is think about the order of operation, or even write it in front of you first, so you can follow it. So the very first thing we need to do again is always start from the parentheses, and that means inside of them, not multiply or something. It means work inside if possible, if you have them. If you don't have them, that's fine. You move on to the next one. So we evaluate only what's inside. Everything else should stay the same. Okay, nothing else changes. So write the whole expression. The first one we did here was the parentheses. Okay, so the parentheses is done. What else is next?
Exponent.
Exponent.
That's right. That's right. So after the parentheses, we need to do the exponents. So we're going to do this, not the multiplication. So we have an invisible multiplication here, as we said, but it's not done yet. See, the multiplication comes after the exponent. So we're going to do the exponent, then go to the multiplication. So this is done first. This is done first before we, that's right, 3 to the second, as we said earlier, 3 times 3, not 3 times 2, 3 times 3, which is 9. And again, bring everything else down. Okay, we're done with the exponent. What is the next operation? Here.
Multiplication.
Multiplication. That's right.
45.
Multiplication.
45.
Very good. So 45 plus
And
10.
50.
55.
That's right. Lastly, the only operation left. And that's your correct operations. Everyone should get the exact same answer when you do this, because we follow the same order. You can't, do something before the other. You gotta go by the order of operations. So we did the parentheses first, then the exponents, then we evaluated the multiplication, finally the addition. If you don't have an operation, you skip it. You go to the next one. But start again looking for parentheses and the other operation, the other ones after that. So here we had 1, 2, 3, 4. So we had 4 steps, 4 operations. It could be even longer than this. For example, you may have 10 plus maybe 3 and some parentheses. Let's say 8 minus 6 to the 4th, and maybe some other operation, maybe a subtraction here. Okay, this one is a little longer. You have more terms, more numbers. What exactly we do first here?
The parentheses.
the parentheses.
Parentheses.
2
That's right. Always start from the parentheses first.
Mhm.
That's here.
2.
That's right. That's 2. Only
Mhm.
do that operation. Don't do anything else. You're just gonna get yourself confused. Just leave everything else the same. Just write it down one thing at a time. One thing at a time. So we did the parentheses. Then
The
Exponences.
exponent.
Exponences.
that's right, exponents. So after the parentheses, here, we gotta do the exponents. So again, don't just look at it and stare at it, try to invent something. It's all here. So do the parentheses, then look here what to do next, exponent, then you look for the exponents. If you have them, do them. If not, move on to the next. Don't try to do the addition or try to do the multiplication. That would be wrong. So let's do the exponent, 2 to the 4th. 2 times 2 is
16.
That's right. So when you have exponents here, if you know the answer, that's good. You can write it down. If you don't see it, do it on the side. don't expand it here, okay? Try to keep this organized and clean. Do it on the side. Don't expand it here. It's just gonna add the mess to your expression. So expand it on the side, 2 times 2 and so on. Then do 2 at a time. 2 times 2, that's 4. Multiply 2 times 2, that's 4. Finally, that's 16. So that's why we have 16 here. Again, you don't have to put this work here, do it on the side so you don't mess up the expression. Everything else should stay the same. Only did this first, so parentheses, exponents,
Exponent,
then
the multiplication.
The addition.
multiplication.
And the addition.
No, before the addition, the multiplication.
Then you close 48.
48.
That's right. So we have an
Yeah,
invisible.
16 times 3.
That's
That's right. We have an invisible multiplication here, everybody. So between the number and the parentheses is an invisible multiplication. So we're going to do the multiplication. That's right. That's 48. Bring the other numbers down. And now we have these two. We do them left to right. Left
Left or right.
So
So
this
we have
and this.
58.
Mhm.
58
So-
minus 20.
50.
So that's right. So we're going to do the addition first.
And then
And-
the result is 38.
30.
38.
That's right. The only operation left is 38. And that's it. Again, everyone should get the exact same answer if you follow the correct order of operations. So it's 38. Multiplication exponents, parentheses, multiplication, then we did the addition, finally the subtraction. Okay, so that's basically what we do every time, no matter how many operations you have. You could have a bunch of them. That's not a problem, as you can see. The answer, the final answer should be the same.
Professor, I know the R is for parentheses and so on, but what the
The
R
P.
stands for?
The P, which R?
Oh, the P, sorry.
P is a parenthesis. right?
Parentheses.
Oh, it's
Mhm.
P for parentheses. That's why I was so confused.
All right. Let me give you another one here. So sometimes you may see brackets like these, an expression, and for example, 15 plus 2, and inside the brackets you may have some expression, let's say 3, maybe 3 and 5 to the second, like this, maybe minus 10, or minus 25, something like this. So, or we make this a little different here. So I want to put maybe 4 here to the power 7, maybe minus 10. Okay, so you could also have all this together here. Pretty much have almost all the operations here except for division. So when you have the brackets, they're just bigger parentheses. When you see them, that means we need to do them first. The inside of them must be done first. And inside of the brackets themselves, you may have a bunch of operations. So you apply another order of operations inside the bracket. So these bigger brackets, most of the time they would have parentheses inside of them. So basically what we're doing here is we're going to work inside the brackets. We're not doing the addition yet, even though it appears first. Also, what is the operation here again between 2 and the brackets?
Multiplication.
Multiplication.
Multiplication. So we're not doing that yet. Inside. Instead, we're going to work inside the parentheses. So these are going to stay here until this is completely simplified. This will turn out into one number, for example, 6. Once we're done with that, then we'll see what to do next. So for now, let's focus on the inside of the parentheses, of the brackets. So inside of the brackets, again, we have more operations. So let's apply the order of operations again here. So what do we do first? The very first inside the
one in the
brackets.
bracket.
First parenthesis, 5 minus 4.
That's
Which
right. So we're
one?
going to do the parentheses. That's right. 3
Mhm.
1
1
to
of
the
7.
power.
7.
That's right. We just rewrite this smaller. So 3. You have 1 to the power 7 minus 10.
minus 10.
That's right. We're still going to work inside the parentheses. Let's bring the other numbers down. So 2 multiply. So inside the brackets, we're following the order of operations. So we did the parentheses. Now we're going to see if we have this and this and this. So what comes after the parentheses?
1.
Exponent,
Add the exponent,
The exponent.
One.
which is
Right, so
7.
7.
Not 7.
Is 1.
1,
It's
sorry.
It
One,
is
yeah.
1. So 1 to the 7th or to any number is that means
one.
1
Okay,
times
one.
itself. 1
One.
times 1 times 1. Yeah. So 1 to any number would be itself. Bring the 3 down, negative 10,
Mhm.
and we're still working inside the parentheses or the brackets.
Multiply the 3 times 1.
That's right. So now we have a multiplication here and a subtraction. So we can evaluate this first.
3
Let
minus
me-
10.
I don't want to run into a negative. We haven't done the signs yet. Let's turn this into a 13.
It's gonna be
Yeah, so let's turn that into a 13 to avoid having negatives. We haven't seen the signs yet. So now we're down to 2 operations, multiplication and subtraction. Of course, that's first. We did this before that. 13, take away 10. The last thing inside the brackets,
3.
3, yeah.
that's right, 3. So as you can see, the brackets are done. We have one number here, and now we can get back to the other one. So you have addition, you have multiplication, and again, which one is done first?
Multiplication.
Multiplication.
That will be
Multiplication.
6.
That's right, multiplication.
6
Finally,
and 9.
you have
21.
21.
Oh, I'm sorry, I didn't change the sign.
Okay, so finally, that's the final answer, 21, for this whole thing. Again, just because you see a lot of numbers and signs and parentheses doesn't mean it's difficult. Just remember, you do have the order just right in front of you. You have the expression. Don't think too much about it. Don't invent anything. Just follow the order. PEMDAS, step by step, start from inside the parentheses, or if you have the brackets, usually they're bigger parentheses, just start inside of them. Again, just because an operation appears first doesn't mean you have to do it first. So every time you see a bunch of operations, immediately think about PEMDAS.
Can you scroll up, please?
Where?
Like scroll up by the PEMDAS, however we say, PEMDAS.
PEMDAS.
Thank you.
Okay, so that's the order of operations.
Go a little bit upward, Professor, just real quick.
Okay. All right. Any questions so far, everybody, about all of this?
Everything clear?
Okay. Everybody else, you good?
I'm good.
That's good.
Okay. Now let's talk a little bit about the exceptions they mentioned here. Said that these two, when they are together next to each other, we do left to right. Also, these two, left to right. So here's what it means. So this is PEMDAS again, in front of us. Let's say you want to do this. So which operation do we do first here?
The multiplication.
Multiplication.
Division,
Multiplication.
multiplication, left to right.
No, division, 'cause it's left to right.
Division. It's left to right.
Okay, left to right, that's right. So some people say multiplication, some people say division. Just because it says here multiplication first, that doesn't mean it has to be done first. When these two are together again, we do them left to right. When they're together, whichever appears first, we do it first. So in this case, we are doing this because it appears first among these two, but
5
only when
times
they are
4.
next to each other. So we're going to evaluate this first, left to right. So that's 5. Right, and then 20. So
20.
this is done left to right. Again, it's an exception to this. So these two here left to right, also these two. So left to right, and that's exactly what we did here. Also here. Let me give you another one. So let's say you have 2 or 6 times 2 divided by 3. Again, we have multiplication and division next to each other. Which one we do first?
We're doing the multiplication first.
Multiplication
Left
first.
to right.
Exactly, left to right. So again, whenever you see multiplication and division next to each other, we do left to right in your expression. That's the only time, and also we do the same thing here. That's the only time, the only 2 exceptions when you can start from the first one on the left. Any other time like this, you follow the order. So we're gonna do that first. That's 12. Divide this by 3. Of course, there would be 4. Left to right. Same thing applies to addition and subtraction, as I said. So if you have, for example, 10, take away 7 plus 4. Which operation is done first?
Left to right. 10.
That's right. That's right. Again, left to right. Even though here we see plus first and then subtract, doesn't mean we have to do this first every time. When they are next to each other, directly next to each other, like this, we do them left to right. If they're not directly next to each other, if they're separated by something else, another operation or something, then we would use the normal order here. So that's 3
Plus
is
4.
first, plus 3 plus 4, and that's 7. Okay, so all these are different examples. What about if you had 12 plus 4 minus 10? What do we do
It's gonna
first
be
again?
addition to
12 plus 4 first.
That's right. Again, left, then the right. This one first. Here
Yeah,
we
it's gonna
did the subtraction, but here again, the left first. So that's 16 minus 10, which is
6.
right 6. If you do it in the other order, you would not work. If you do this first, it's not going to be the same. It's going to be a different number, and you may not make sense either, because if you try to do positive 4 minus 10, it's not going to make sense, especially if we don't know the signs yet, the negatives and so on. Okay, so be aware of these exceptions. Okay, you may forget them, but keep them in mind. So left to right here, and also here. And okay, everybody understands these exceptions, the left to right.
Yes.
Sir,
Yes.
so left to right theory goes only with if multiplication and division together or plus and minus together. That's it, right?
Oh,
Exactly. You have to be
Right.
directly next to each other, not separated with something else.
Okay, thanks.
Okay, that's good.
Yeah.
So, so the order of operation not only applies to the whole numbers as we see here, it also applies to fractions, it applies to decimals, everything we've seen basically, all the operations we've seen. If we have a bunch of them together, so far we've only multiplied, for example, 2 fractions or added 2 fractions or divided, but you may have a whole expression with 3 or more fractions. One expression, divide, multiply, whatever. So if we have more than 2, if we have more than 1, then we need to apply PEMDAS. If we have more than 1, so for example, here we have 2 operations, one of them has to be done before the other. So for example, for fractions, so let's say, so you may have, for example, 2 or 5 over 6, maybe added to 1/3 multiply 7 over 2. Okay, so as you can see, this is not something we've done yet. It looks unfamiliar because we're used to only doing 2 fractions at a time, but it's not always the case. You could have 3 fractions, you could have 7 fractions in the same expression with different operations, exponents, and so on. So once you see this, before it doesn't have to look confusing. Don't panic, look at it first. Try to figure out the order. You say, what do I do first? Once you figure out the order, then you figure out how to do the operation. So we do know how to do all the operations. We learned everything about fractions. We learned everything about decimals. We just need to do it in the correct order. So here, the first operation we do is
The multiplication.
multiplication. So you got to focus on the multiplication. Again, PEMDAS. So then once you figure out the order, now think about how to do this multiplication. So we're doing fractions. We've done this over and over again. How do you multiply these two?
Straight, so it's 7/6.
7/6, straight across. So you multiply straight across. Reduce if possible, whenever possible. Try to maybe simplify something, but if not, just multiply. So 7/6. Bring the other fraction down. 5/6. Then, before adding or subtracting fractions, what do you need to check?
If the bottom is the same.
The same.
That's right.
The
That's right.
denominator.
Exactly. So make sure you have the same denominator. If you don't have the same denominator, you need to find one. You need to find a common denominator, as we did before. We spent the whole class on this. Luckily, here we have the same denominator. So what is this equal to?
It's going to be 12/6.
12/6.
That's right. Can we reduce it?
Yes.
This will be
By 6. So it's big.
It's
2
2.
over 1.
be 2. 2/1. 2/1 or simply 2. That's right. 6 goes into 12 exactly twice. So just going to write 2 here. And it's not that bad, as you can see. It's a pretty simple thing. So think about the order first. Think about how to do the operation. And it doesn't matter how many fractions you have, as long as you follow the order of operations. You follow all the operations. By now, everybody should know their fractions well. We reviewed this extensively. We did the decimals and all that stuff. So know your operations first, know the order. When you combine them together, you can simplify some complex stuff like this.
Professor, question.
Mhm. Go ahead.
Let's say that it happens that the first operation, the multiplication over there, gives us a big number. We can simplify before adding
Always,
it to the
yes, always simplify first. Simplify before multiplying, it's better. If you don't simplify first, you're going to get big numbers and you still have to simplify them. Otherwise, you'll end up in troubles here with big denominators, and it's going to be hard to find the common denominator for a big denominator. So simplify first before multiplying and dividing. Let me give you another one here. So 2/3, for example, and you want to divide this by maybe something else. Let's say something in parentheses. Let's say maybe 5/3 minus 1/3 or 1/5. Actually, maybe 1/7. Just like that. Let's see, 5/3. Actually change this a little bit. Maybe 4 and 5 here. So again, see a bunch of fractions, parentheses, and so on. This doesn't have to be confusing or have to look complex. Again, think about the order first. Before you think about how to do what operation, think about what should they do first. What do you need to do first?
Parentheses.
Parentheses.
Exactly. Parentheses first. Inside the parentheses, now we have a subtraction. Now think about the subtraction of fractions. What do you need to have? What do you need to do first when subtracting fractions?
Find the
Find
log.
the common denominator.
Exactly. It looks like the denominator here is not the same. So don't just subtract or add right away. We need to find a common denominator, which is
15.
15. So we have 15 here, 15 here.
15.
So we need to change these into new fractions of 15. We're going to times the first one by
20.
to turn 3 into 15
Times 5 is 20.
by 5 and by 5 also here. That's right. And the next one, to make it 15, we're going to times it by.
Times 3. So it's 3.
That's right, by 3. So again, we spent a whole class on this previously on how to find the LCD and add and subtract. So again, if you missed that class, make sure you review it.
20,
You go over it.
1.
5 times 4 is 20. 1 times 3, that's 3. Good. Now we can go ahead and subtract since we have the same denominator. Go with the 3,
Same
teacher.
denominator, and then the top is 17.
15 over 15, 17.
That's right. 17 over 15.
But you need to turn
Division.
it. No.
That's right. So we're done. We're done with the parentheses. So we're done with the parentheses and subtraction. Now
And
we
there's
have,
no way to simplify that.
we'll see if we can simplify. So now we're done with
that's what
subtraction
I'm
of
going-
fractions.
So you wouldn't
Hmm?
simplify that 17 over 15 first?
You can.
Of course, always try if possible, but you can't simplify this. You can't simplify 17 or 15.
The only way of simplifying that is turning it into
Turn
a
it
mixed
into a mixed
number, and
fraction.
that will be
That's right.
harder.
Mixed fraction.
But
Flip
we've
Yeah,
not
that
done-
would make it harder to make it a mix.
Mhm.
Keep and flip.
Okay, so first try to simplify it, meaning try to maybe cancel the same number, the same factor from both. Don't make it a mixed number yet. We don't need a mixed number. We still need to do the division. So now think about the division of fractions. How did we divide fractions before? What do we do first?
Keep the first one and flip the second one and make it multiplication.
Exactly. Keep, change, flip. Keep the first one.
Multiply.
That's right.
15
Change the division to multiplication and 15 over 17. Now we have a multiplication. So again,
You go-
before you go ahead and multiply your fractions, always try to reduce, simplify, so you avoid getting large fractions. Can we reduce anything here? If so,
Yeah.
how?
Reduce 3 and 15.
Exactly. So can't reduce this, can't reduce this, can't reduce this way. Nothing goes into both. But here, the 3 goes into both. We can reduce both by 3. The 3 goes into 3
2,
One,
1,
one time, right? 3 into 3 once. 3 into 15,
5. 5.
Sorry.
5 times. It's much easier now to multiply these smaller numbers. So 2 times 5.
10,
10. 1 times
17.
17. That's right. Is 70. As you can see, you get a nice simplified answer. You don't have to
No.
simplify it. So 10, 17, it's proper, it's simplified. That's again why it's very important to reduce first. Always reduce before the numbers get bigger. Okay, so
I'm a little confused.
what's confused? Where?
When you started off the 2, 3, in the bracket, is that a 53 and a 35?
Get closer a little to your microphone. Can't hear you clearly.
By the 4, 3 and the 1, 5, that's a 53.
No, we times. We're looking for the common denominator. This is a multiplication. Times 5 times 5. And this is times. Okay, this is times 3 and times 3. Okay, so just multiplying to find a common denominator. Okay, any other questions, everybody? Everyone, most of this is fractions, what we've done in the past few classes. The only new thing today you need to know here is we did the parentheses first and we did the division. Okay, the rest was fractions. So again, if you have issues with the fractions, make sure you review the past 2 classes or 3. Also here, the only new thing today is the order. So we have to do this first and then this. So parentheses first, find the LCD and so on. The second one was the division. Keep, change, flip, and that's our answer. Okay, everybody, all clear? Any questions here?
No.
Any questions before we move on to something else? Please let me know. So that applies to the order of operation, like I said, applies to fractions, as you see. Also applies to decimals. We learned everything about the decimals again last time. So everything we learned about decimals applies here. You may have a bunch, instead of just addition or division of decimals, you may have a bunch of them together. Let's say maybe 3.5, for example, minus maybe 2.4 added to 6.3. So again, always try to figure out what to do, then figure out how to do it. So we learn how to do everything with decimals, fractions, and so on. So when you have a bunch of them together, you want to see what to do first. And
We're subtracting first, left to
Left
That's
right.
or right.
left to right, just like we did here.
Mhm.
Like we did here with we had subtraction and addition. We did subtraction first. Same thing here. We're going to do subtraction first before the addition. So as you do this, so refer back to everything you learned about decimals. So if you subtract 3.5 and 2.4, we'll get 1 and 1. That's right, 1.1. Bring down the addition, 6.3. So 6.3 here. Add,
7.4.
that's right, 7 plus 4.
7.4.
So plus 7 plus 4. Or it could be divisions, it could be multiplication. Again, we learned all of this in the previous class. So make sure you know all your operations first, okay? So this doesn't get confusing. Review all your fractions, all the decimals. If you missed the class, you'll find the recordings of the lectures on Blackboard. Then combine this with the order of operation. If you don't know how to do the operations, you only know the order, it's not gonna help. You may know the order, but you still need to know how to do each operation, just like we covered before. So decimals, fractions, whole numbers, exponents, all these together, we mix everything up in one operation. We can simplify complex expression, bunch of operations and numbers. And you'll see plenty of these in the homework, plenty of examples, various examples of these. The more you practice, of course, the better, the easier it gets. Okay, any questions here, everybody, about any of this stuff? This is basically it for the order of operations.
Professor,
Any questions? Yeah.
I don't have a question about this, but I do have a question about the homework. So maybe towards the end, if you can help me.
Sure. At the end,
Professor,
after this
give us
practice.
an example with a division.
Say that again.
To give us an example with decimals and a division.
Okay. I'll give you one in the practice. I'll put one in the practice for you. I will put some division and multiplication. All right, so homework questions. Remind me after we finish the practice, and we'll go over that. But if you have any questions right here, please let me know first before the practice. So let's start with exponents. Again, the question might be evaluate or simplify. Maybe 2 to the 5th and maybe 3. 3 over 5 to the second minus 7 or minus 9 to the second, another minus 9 to the second. And some order of operations. Let's see. So this minus this to the 4th power plus 10. The 17 minus that's 14. Okay, another one with decimals. Let's say um, five point zero divided by 0 point, actually 2.40 divided by 0.8, and maybe multiply this by 1.5. Then some fractions. Okay, so that's your practice here. A little bit of everything. Exponents, order of operations, decimals, fractions. So give this a try, everybody. So again, as I always say, this is the moment where you test yourself. This is where you actually learn it. If you know how to do it, you should be able to do it now. There might be no other time to learn it, but this is the best time to actually test yourself. Give it a try, look at the examples, all the rules we saw. Give you about, please mute your mic, whoever has noise. Mute your mic, everybody, when you're not talking. Okay, give you about 10 to 12 minutes to finish this. Same time, you may take a short break. If you would like to take a quick break and then come back to the review, you can do that. So I'll check with you in about 10 or 12 minutes. I'll be right back. Everybody, are you done?
Yes.
Okay, everybody else?
Yes.
Yes.
All right, everybody, please, if you're done, let me know so we can go ahead and work these problems together. Let me share the screen again. All right, so the first one here, what do you guys think of the first problem, 2 to the 5th power,
32.
32.
32?
32.
Everybody agrees?
Yes.
30.
Any objections to that?
No,
Okay,
it's good.
No,
seems
I
like we
think it's
have
good.
Yes.
we have a consensus, right? We have a unanimous decision.
Mhm.
Good. Let's move on to the next one. What do you guys think of this? 3/5 to the second.
9/25.
9/25.
5.
Yes, 9/25.
Now over 25.
That's right. Everybody agrees. So it's 3/5 times 3/5, 9/25.
Yes.
These two here, a lot of different. What is the first one equal to?
Minus
Negative 81.
Negative 81.
Negative
Minus.
81.
Negative 81.
Negative
right.
81. Yes.
Okay, everybody agrees on that?
Yes.
Yes.
That's right. That's the right answer. The other one, a little different.
Positive
81.
81.
Exactly. Positive 81. Okay, that's good. So always again, pay attention to the negatives here when you have them in the expression. Good. Now let's move on to the order of operations. What is the first operation that we do here?
Parentheses.
The parentheses, 11 minus 9.
Exactly. So the parentheses first. So before anything else, make sure you write the whole thing.
Yes.
Expression stays the same. So only do one thing at a time. So that
2.
2.
2. Okay.
Plus 1 and 4.
1 and 4 plus
Plus
10.
10.
Plus 10.
That's right. Plus 10. So we're done with the parentheses. What do we evaluate next?
5.
5 times
5 times. You got 16.
16.
Not 5. Not 5 yet.
16.
Okay,
Ah, that's
Exponent.
16, but we write like
16.
5 and then parentheses 16
16.
That's right.
plus 10.
10.
This next. That's 16.
16 plus 10.
That's right. Plus 10.
10.
Now we have two operations, multiplication and addition. Which one do we do first?
Multiplication. That will be 80
80.
Okay.
Plus
plus 10
10. 90.
is 90. 90. Mhm.
That's the answer.
Exactly. Okay, everyone, we got the same answer. Any?
Yes.
Yes.
All right, very good. If you have any questions, everybody, please let me know. If you have any think about these steps or any of these questions, let me know. Another one of these order of operations. And again, we would do
Parentheses.
And plus parentheses.
Parentheses.
First.
3.
3.
parentheses,
3.
that's right, 3.
Yeah, 3.
10 plus
3.
3.
Okay,
And then it's 1 and
Second
2
power.
minus 20.
Plus 20.
that's right, exactly. So we're done with parentheses.
Mhm.
So again, here is the order.
Mhm.
Next, we will do
Exponent.
Yes,
Exponent.
which is 9.
exponent.
9. 9.
That's right.
Mhm.
Only the exponent and just write everything
And-
else down.
Mhm.
Okay, after the exponent,
And that will be 27.
Multiplication.
10 plus 27.
1 plus, yes.
exactly. So 10
Then
Plus 27 minus 20.
Minus 20.
Menos 20.
that's right. We did this next.
Mm,
Now we're
You
down to two operations.
37 minus
Plus
20.
37.
37 minus 20.
37 minus 20.
That's right. Everybody's
17.
right. So left to right. 37 minus
Min-
20. And of course, that's
17.
17.
17 is this answer.
very good. You see how the order is all the same. So everybody follows the same order, same steps, you get the same result. That's why,
Yes.
again, we have this universal order of operations to get the same result. And then it could be decimals, they could be fractions, as I said before. Which operation do we evaluate first here?
The division.
Divide.
Division.
Mhm.
Division. That's right. Left to right. So left to right. First, again, be concerned about the operations before the order of operations before getting concerned about the actual operation. So here we know that
3. So you minus that would be
that's right. We need to do the division first. 2.40 divided by 0.8. What did you guys get?
like it 240 divided by 80.
3.
240 divided by
3.
give it 3. 3.
3.
Yeah, 3.
Professor,
Okay.
can you make that division on the side? I made it, but I just, I want to see it.
Me too. Like
So-
I made it, and I got like 4.5, but I want the details. So I.
Okay.
I got
So-
3, but I want to see the division.
Okay. So what's the first thing you do when you have division of fractions of decimals?
You move
You need-
you move the dot.
That's
Decimal
right.
form.
Move it twice. Move it twice.
Mhm.
Okay. So this will be 240
3.
divide
80.
80, right?
Mhm.
So if you do the division,
80.
so how many times does 80 go into 240? It goes exactly a specific number of times. How many times is that?
3.
3.
Yeah, 3.
3 times 80 is 240.
The
So-
only
Okay.
thing is that, Professor, I didn't
Mhm.
move the point. I didn't move the dot twice. I only moved it once.
So
You
you
have
need
to
to move it twice. Because the
Me
size time.
too.
And
Yeah,
the
I-
result is the same.
Is for 0.
Right, right. So always move the same number of times as we saw before in the previous lecture. So this will be 3. You can make it 3.00. It doesn't matter because it's even
Oh, I
here.
thought that the last 0 on 2.40 didn't matter.
Yeah, it doesn't. You could have done it. You could have moved it once and once, which
Yeah.
would have been the same thing. It would have been easier actually. It would have been the same thing.
That's
If you
what I
this,
did.
It's more
Okay.
easy.
Me too,
I
actually.
mean 8 here. Once, right? It would
And
have
then
been
8
even
times
easier.
3 is 24. So
So,
that's what
yeah,
I did. But that is only because it's a 0, right? If it was another number, then I had to move it twice, right?
That's right. Yeah. So
And I put
either
the
way,
same amount of zeros on the 0.8, the same amount of zeros of numbers that I have, right?
that's right. So if you move
I'm still
one
having
once,
issues with the
move both
division,
once.
that's why.
Okay,
I'm
so
still
if you
having
move
issues
once,
with the division,
you
and that's
move
why I'm
both
asking.
twice, or you move both once. Make sure you move both the same number of times, whether it's once or twice, or these are the same number of times. Then you do the division on the side. Once you have whole numbers, you do the division. Okay, then multiply this by 150. What did you guys get from the multiplication?
4.5.
4.5.
That's right. Again, do your multiplication on the side. 4.5 or 4.50, same thing. Okay, so
Professor, can you make that